Hi, welcome back. It's Professor Ridge and today's lesson on 5.1, Introduction to Polynomials and Polynomial Functions. So we'll start off with just reviewing all the terms. Hopefully you're familiar with these terms, but we'll just go ahead and recover them. So what's a monomial? So the monomial is just a number or a variable raised to a power, or a product of numbers and of variables raised to powers, provided the powers are whole numbers. So examples would be like 3x squared. That's a monomial. I can just have a number like 8. Just x to the 5th. I can just have x. I can have 12x cubed y to the 3rd. Those are all monomials. Four x to the negative 3 is not a monomial because negative 3 is not a whole number. Whole numbers are 0, 1, 2, 3, no negatives. How about, let's say, or not monomials. How about 5x to the 1/2? See, that's not a monomial because 1/2 again is not 1/2 is not a whole number. Okay, so both of those are not monomials. A polynomial is a monomial, so it could just be one term, or a sum of monomials. So we can have 3, 4, 5 terms. Okay, when we talk about the degree, okay, so a degree of a monomial is the sum of the exponents of the variables. Now the key thing here is this is for a monomial. Now for a polynomial, the degree of a polynomial is the degree of the highest degree term. It's not the sum of them, it's just the highest degree term. So we'll do an example of that in a minute. Get through all these definitions. The coefficient of a monomial is the number part, or the number in front, if you want to think of it that way. And the leading coefficient the leading coefficient of a polynomial is the coefficient of the highest degree term. And the reason we say that is because normally we put things in descending order, so you put the highest degree term first, and the coefficient of that term would be the leading coefficient. So when we talk about leading coefficient, we're usually saying that you're going to put it in descending order, and whether it is or not, it doesn't matter. The leading coefficient is the coefficient of the highest degree term. Okay, so let's cover all the terms here. So for each of these polynomials, identify the term, the degree of each term, the leading term, the leading coefficient, and the degree of the polynomial. So for the first one, right, we got 4 terms: 4x cubed, 5x squared, negative x, and 3. And the degree of the first term, well, it's the power of the exponent, so it's 3. Power of the variable, I should say, or the exponent of the variable. For 5x squared, so that's degree 2. For negative x, what's the exponent if you don't see it? And you should say 1. Then for the constant, there's no exponent, no variable, I mean, it's x, or you can think of it, it's x to the 0. So either case, the degree is 0. Leading term, remember that's the highest degree. Well, I didn't write it down anywhere, but that's the term with the highest degree, just like the leading coefficient is the coefficient of the highest degree term. So leading term would be 4x cubed. The leading coefficient would be that coefficient for that term. And the degree of the polynomial is the highest degree of each of the terms. So 3 is the highest degree for the whole polynomial, so the degree of the polynomial is 3. Alright, so for b, let's see how you do it if there's more than one variable in it. So we got 6x squared, 8x squared y cubed, negative 20x y squared. So just 3 terms. So the degree of the first term is 2. Now, for a monomial only, you're going to add the exponents of the variables. 2 plus 3, that's going to get you 5. And then for the last term, x to the first, y to the second, that's going to be degree 3. So the leading term, whether it's in descending order or not, usually that's kind of confusing with more than one variable, but still the highest degree term is degree 5, so the leading term would be 8x squared y cubed. The leading coefficient would be 8. And the degree of the polynomial will be, you take, again, it's the highest degree term, which is degree 5. So it's a 5th degree polynomial. Okay, so we can classify polynomials by their degree, which, so we talk about the degree of the polynomial. And we can also talk about by the number of terms. So a polynomial with 1 term is a monomial, 2 terms, binomial, 3 terms, it's a trinomial. And then, of course, descending order. So descending order is you're going to arrange the terms from the highest degree down to the lowest degree. And then going the other way is ascending order. And that's arranging the terms from the lowest degree to the highest degree. Typically, we do descending order. There are some cases where we do ascending order, but it's more common to do descending order. And that's why I prefer it. Okay, so we can use function notation for polynomials, and we call that a polynomial function. So I can define a polynomial and give it a name, like p of x, using my function notation. So this is polynomial p, and the way that I find the value of the function is just like evaluating an expression. If I want to know what p of 3 is, I put in 3 for all the x's. If I said evaluate p of 3, so you just put in 3 wherever you see an x. Punch that in your calculator. So let's see, 27 plus 27 minus 6 plus 1, 54. $49. If I wanted to evaluate p of 1, just put in 1 everywhere x is. So you get 1 plus 3 minus 2 plus 1. And that gets me 3. Okay, so we can use the function notation for polynomials, and then we call that a polynomial function. No big deal. Okay, so to add 2 polynomials, you just combine like terms. So we just drop the parentheses and combine like terms. And again, I like to do descending order. So x cubed, 5 plus 8. 5 plus 3 is 8. X cubed. X squares. So that would be plus 5x squared. X's. Plus 2 plus 3 is plus 5x. And then the constants. 7 and 8 is 15. And then you have it in descending order. And that's a good habit to do too, because that way you don't miss anything. Alright, so combine like terms. Now to subtract polynomials, well, first let's talk about opposite of polynomial. So the opposite of a polynomial p can be written as the opposite of p, so minus p. Or equivalently, you can just change all the signs I forgot to write change, by changing the signs of each term. Okay, so you just change all the signs. Let me give you an example. Okay, so write two equivalent expressions for the opposite of this polynomial. So again, there's the two ways I can do it is I can put the opposite of it. So here, so the first method would be just put a minus sign outside a parenthesis like this, or equivalently, you just change all the signs of the polynomial. So it'll be minus 4xy, x squared y, plus 3xy, minus 2x, plus 8. So those are the same thing. Those both mean the opposite of the polynomial. Okay, so to subtract two polynomials, so if I did p minus q, I'm just going to add the opposite of the second polynomial. Alright, so let's try one. So let's do exercise 79 from the book. So you're going to leave the first polynomial alone. I could have dropped the parentheses, so. And then you're going to distribute the minus sign to the second one. So you change all the signs inside the second parenthesis. I don't know where that 5 came from. Alright. And again, I could have dropped the parentheses, so just ignore them. So negative 3x squared, negative 1, that's negative 4x squared. Positive 2x minus 5x, that is negative 3x. Positive 9, positive 4, that's positive 13. And that is the solution, or the subtraction, the answer subtracting. Okay, let's try number 86. Again, I'm going to leave the first one alone, and I'm going to add the opposite. So I take the second parenthesis. So I'm going to add the opposite. So I'm going to take the second parenthesis and change all the signs. So it'll be plus 9x squared y squared minus 4y cubed plus 7xy. Now just combine like terms. So let's see. Let's start with x squared y squared. So x squared y squared. So that's 5x squared y squared, because I got negative 4, positive 9. Now let's see, x's, xy's, we'll do that one next. 10xy, 7xy, 17xy, and then we just have the y cubed. So we got negative y cubed, negative 3y cubed, and negative 4, which gives me negative 7y cubed. And there's my final answer. Okay, so let's look at number 90 now. So I have 9x squared plus 1 minus x squared plus 7 plus 4x squared minus 3x. So we're adding these three binomials, and we're going to subtract the middle one. So our first step is you're going to, either you can think of it as distributing the minus sign or adding the opposite. So you're going to change both of those signs. Okay, and then since this is a plus, we can just drop those parentheses and just write everything down the way it is. Alright, now we're going to combine like terms. So I got 9x squared minus 1x squared plus 4x squared. So that is 12x squared. And then just this x, so minus 3x. And then plus 1 minus 7, which is minus 6. And there's my final answer. Okay, so that concludes our lesson for 5.1, and go to my math lab, complete your exercises there, and I'll see you next time.